Hi static engineers, welcome back. Today we discuss about one of the important topic, pressure. What is pressure? Why it is very important? If you see my screen, you can able to see that there are different kinds of pressure which I am listed here. Almost for one vessels we are using more than 5 pressures. Actually these 5 pressures are only for internal pressure. If you ask me to differentiate the pressure which we are using in the pressure vessel, one is internal pressure and another one is external pressure. If you speak about internal pressure, it is a vast topic, and about external pressure, that is also a very big topic, so we can't able to combine these two content in a one video. So I will focus only internal pressure in this video, and we will create a separate video for the external pressure. What is internal pressure? First, what is pressure? Force divided by area. Can we use the same pressure in the pressure vessel field, in the ASME field? No, we can't able to do that. We have 5 different kinds of pressure. I already told: operating pressure, design pressure, maximum allowable working pressure, we call it as MAWP, hydrotest pressure, and maximum allowable pressure. What are these kind of pressures? We will discuss each and every pressure in detailed manner in this video. There is a common mistake that we will do as a junior engineer. When I am starting the career, I also done the same: gauge pressure and absolute pressure. In this graph you can able to see that this red line is the local atmospheric pressure we are experiencing day to day life. Even now you and me are experiencing this local atmospheric pressure. And what is the absolute pressure? The gauge doesn't shows the absolute pressure. The absolute pressure is, we are in the earth surface. Above the surface there is atmosphere. That atmosphere has different kinds of layers are there. There is some air and everything is there, right? You know that air has some weight. If we remove the atmospheric pressure, that is called as absolute pressure. What the gauge will give is the gauge pressure. The gauge doesn't provide you the atmospheric pressure. Some gauges are there, vacuum gauges. The vacuum gauges will provide the absolute pressure, but almost all the pressure gauges are giving our reading as atmospheric pressure only. We are pressure vessel engineers, right? Why we are concerned about this absolute pressure, this gauge pressure and everything? Absolute pressure, the full vacuum, partial vacuum, everything comes for external pressure. If there is any external pressure, we will experience this absolute pressure like full vacuum and partial vacuum. Not only in the terms of external pressure, also if there is any pump which is connected to the vessel, there is any steam in steam out condition is there, those times we will use this absolute pressure. Operating pressure, pressure required to keep the normal process running smoothly. Vessel needs to be run at 1 bar, means that is the operating pressure. The operation requires such pressure. The vessel which face day to day life, it is maintained and monitored continuously by the control room. If there is a big plant, it is monitored by the control room. Otherwise it will be monitored by the particular operator or any other kind of systems they have in their organization. What is design pressure? Design pressure is the pressure which is maximum expected during the operation. If there is any failure in control valve or any other places, the vessel will experience a maximum pressure which is not designated for that particular vessel, but it will face the maximum pressure. That is the design pressure. That is the pressure we use for our calculations in ASME Section VIII or in whatever code you are using. This design pressure is the pressure we are using for the calculations. And for the operating pressure, we are not going to use that pressure in our calculations to calculate any thickness of the shell or anything. We are going to use design pressure to calculate our thickness, and if there is anything we are going to calculate using ASME code, we are using the design pressure. MAWP. Normally this is a confusing factor for almost all the engineers. What is MAWP? In the term itself you can easily able to understand that maximum allowable working pressure. This is the pressure the vessel can maximum able to handle. Why the design pressure and the maximum allowable working pressure are not same? In some vessels it might be same, but it is not common for all. I will tell one example. If a vessel is designed for 8.5 mm thickness, the required thickness is 8.5 mm as per the design pressure, but we will build the vessel using 10 mm thickness because 8.5 mm thickness is not available in the market. We have to go for 10 mm or 9 mm. 9 mm is not commonly available in the market, so maximum we will go for 10 mm thickness. So the pressure taking capability of that particular vessel is now increased. Before we have designed for the design pressure, but the pressure taking capability has increased increased due to the thickness which we are providing extra. That is called the maximum allowable working pressure. Normally the MAWP is governed by the weakest component of the pressure vessel. If the shell is a strongest component, then it won't be a concern. But if we are using a RF pad for the particular nozzle and the RF pad is the weakest part of the cell, means that is governing part of the MAWP. Okay, what is MAP? MAWP. Actually the main difference is just simple thing. For MAP we have to calculate everything in a new condition. That means if there is any tolerance, we don't need to consider those tolerance. If there is any corrosion allowance, we don't need to consider any corrosion allowance. In simple terms, if we are using 10 mm thickness shell and the corrosion allowance is 3 mm, we have to remove the 3 mm and calculate MAWP. But for MAP, we don't need to remove the corrosion allowance or any tolerance, and we need to calculate what is the maximum allowable pressure. Okay, it is not a working pressure, it is pressure the vessel which is in new condition. We can able to calculate the MAP. And finally, what is the hydrotest pressure? The pressure we use to test the vessel, to test the integrity of the vessel. Is a vessel is okay, is a vessel is withstand our pressure, is there any leakage? During those times we use this hydrostatic pressure. Normally the hydrostatic pressure will be in ASME Section VIII Division 1, it will be around 1.3 times of design pressure, plus there will be some ratios are there. We will discuss those things during our detailed sessions. What are the hierarchy of the pressure vessel? The highest, the topmost one is hydrostatic pressure. It is normally highest because we will use this pressure only for testing. And the next one is MAP and MAWP. Normally MAP is the highest one, the next one is MAWP, as I already explained. Next one is design pressure, and the least one is the operating pressure. Now we will discuss about what are the common mistakes we will consider during this design pressure. The first thing is we will directly use the operating pressure to design the pressure vessel. No, we have to check the design pressure first. Using operating pressure for calculating the thickness or anything is completely wrong. We don't have to use that. We have to calculate thickness and everything using the design pressure. That is a first mistake. And the second one is confusing with MAWP and design pressure. Those are completely different. As I already explained that MAWP is higher than the design pressure normally. That is one of the confusion. And finally, we will ignore that design temperatures. Normally what we will do is we will take a design pressure. Okay, I know that SA516 grade 70 material allowable stress is just 138. We can able to directly use that in the calculation. No, you have to avoid that. What you have to do is you have to check the design temperature and you have to check allowable stress for the particular design temperature. These are the common mistakes we need to avoid. And finally, I will give you a bonus tip how to calculate the design pressure. Normally what engineers will do is they will take 1.1 into operating pressure. Take 10% higher than the operating temperature for the design pressure. Yes, we can able to do that, but you have to calculate the static head of the vessel. What is static head? Static head is nothing but if you are considering a vessel as a vertical vessel and you are filling the water inside the vessel, the bottom of the vessel will experience more pressure comparing to the top of the vessel. Why? Because of the liquid weight. So what we have to do is we have to calculate the static head of the particular fluid. What is the maximum design pressure we can able to accommodate in the bottom of the vessel? That is the design pressure we have to use in almost all calculations. Okay, how to calculate that? Rho GH. Rho is nothing but density and G is nothing but gravity of accelerations, and H is the height of the vessel, height of the liquid column. Total density, if you consider the water has density as 1000, the gravity of acceleration it is around 10, it is 9.8 something, so we will take it as 10. And what is the height of the vessel? That you have to know because you know already the geometry is there with you, so you can easily able to calculate rho GH. So you will get the particular static head of the vessel. You need to add that static head into your operating pressure. It is the perfect engineering way to get the design pressure. Okay, we are closing the video. In next video we will see about the external pressure and vacuum. What is the external pressure and how it will affect our pressure vessel, and what is vacuum? Does the external pressure and vacuum is same? Everything we will see in the next video. Okay, bye bye.